Hi, myself Pradeep. I am from Computer Science Department. This course is Mathematics for Computing. Today's topic is recurrences for characters of the symmetric group. Introduction to symmetric groups. The symmetric groups denotes S of n consists of all permutations of n elements. Characters of the symmetric group provide important insights into its representation theory. Understanding recurrences for these characters can simplify calculations and enhance theoretical knowledge. Symmetric group. As we know, a permutation pi is a bijective mapping of a set A on itself. Pi A tends to A. Permutations may be multiplied and form the symmetric group. Symmetric of n equal to Sn equal to Sa. That has n factorial elements, where n equal to mod A. Basics of characters. A character is a complex valued function associated with group representations. Characters capture essential information about the representation, including dimensions and traces. For symmetric groups, characters can be calculated using the cycle type of permutations. Cycle types in symmetric groups. Permutations can be expressed in terms of their cycle structure, which informs their characters. Each cycle type corresponds to a partition of n, which is key in character calculations. The number of permutations of a given cycle type is crucial for evaluating characters. The hook length formula. The hook length formula provides a method for calculating the dimensions of irreducible representations. This formula relates to the characters of symmetric groups by determining character values. Understanding the hook length structure aids in deriving recurrences for characters. Total length of hook equal to I to first to second plus second to third plus third to fourth, which are their lengths. The sum of all lengths equal to total length of a hook. Here d equal to diameter of bar. The total length of this hook is 9d. Recurrence of relations overview. Recurrence relations express the value of a character in terms of previous values. These relations are essential for efficiently computing characters for large n. They often arise from combinatorial interpretations of the characters. Basic recurrences for characters. One common recurrence involves the relationship between characters of consecutive symmetric groups. Specifically, the character values can be often to be computed from those of s of n minus 1 and s of n minus 2. The basic recurrences provide a foundation for more complex character calculations. Example recurrences t of n equal to t of n minus 1 plus n, which means recursive algorithm that loops through the input to eliminate one item. Advanced recurrences and formulas. More complex recurrences can be derived using generating functions and symmetric functions. The use of sure functions leads to further insights in character recurrences. Advanced recurrences can enable explicit calculations for higher dimensional representations. Implications of character recurrences. Recurrences for characters plays a vital role in combinatorial representation theory. They facilitate the computation of characters in various mathematical contexts such as algebraic geometry. Understanding these recurrences can also lead to new discoveries in group theory. This is the flowchart of the recurrences. Example of character recurrences. Examples illustrate how recurrences yield specific character values for small n. Detailed calculations highlight the efficiency gained through using recurrences. These examples serve as a stepping stone for tackling more complex situations. Conclusion and future directions. Recurrences for characters of symmetric groups are a rich area of study with many applications. Continued research may yield new insights into the structure and properties of symmetric groups. Future explorations could focus on generalizations to other groups and combinatorial structure. References. We have three references here. The first one is J.D. Dixon and B. Mortimer. The title is Permutation Groups. The second one's authors are F. W. Anderson and K. R. Fuller. Title Rings and Categories of Modules. The third one here is the author is I. G. McDonald. The title is Symmetric Functions and All Polynomials. Thank you.